in this activity, we're going to try and get an understanding of average value of a function. So the graph of y equals f of x is shown. What is the average value of the function f? Now, this sort of problem appeared as multiple choice questions a couple of years ago, in fact, I think 2 consecutive years. And in this case, the rule for the function was not given. So the idea was that by thinking without using calculus, from your understanding of average value, you should be able to find the average of this function. Okay, now let's try and understand what is being asked. I think of average value as the average height of the function. So the minimum height of the function is 3. The maximum height of the function is 7. So somewhere between 3 and 7 must be the average. So somewhere around here. And in fact, because this function is increasing at a constant rate and then decreasing at a constant rate, it's going to be right in the middle. So as we'd expect, it would be at 5. So I'll just enter, make that interval 5. At 5, we can see that we're exactly half the function is below the line, half the function is above the line. So just by inspection, by thinking, you should be able to find the average value of that function. Now, that's all very well in this case because the function increases and decreases at a constant rate. Let's see if we can come up with a way of using the same principle for any function. So what I'll do, first of all, is find the area under the function from 2 to 14. So menu, analyze graph, and integral 7. The lower bound is 2, so I can just type in 2 and enter. And the upper bound is 14. Just press 1 and 4, enter. And we see that the area under that function from A to B, which is from 2 to 14, is 60 units. Now let's also look at this line here. So let's now consider a rectangle that has the same width. The rectangle also goes from 2 to 14. And I can see the area of the rectangle up here. So I know that the area under the graph of the function is 60. Can I find a point where the area, the yellow area, is also, whoops, can't grab it now, here we go, is also equal to 60, and we can see it's somewhere around about 5, not surprisingly. So enter 5, and lo and behold, it works. So what we're trying to do is, when we're finding the average value, is finding the position of this line, the horizontal line, so that the area is under the function is the graph of the function is the same as the rectangle. So the rectangle is the width by the average height. Okay, so let's try and apply that to a nonlinear function. So find the average value of the function with this rule. So it's a parabola over the interval -1 to 5. So let's do this graphically. So I've already worked out the area under the graph. That orange area is 18 units. Now, what I want to do is find how high I need to make that rectangle so that it also has an area of 18. I can see, whoa, somewhere pretty close to 3. So let's try 3. So I'll edit that, 3, and bingo. So the average value is 3, which means that this orange area under the curve is the same as the yellow area bounded by the curve and the horizontal line. So it literally is the average height of the function. So where does this formula that is on the formula sheet, where does that come from? Well, I know that the area under the graph is the integral from a to b of f of x dx. The area of the rectangle is the width of the rectangle, b minus a, by the average height. Now, when the two areas are the same, the area of the rectangle equals the area under the curve, then I have that expression. If I make the average height the subject, all I need to do is divide the integral from a to b of f of x dx by 1 over b minus a. And that's where the formula comes from. But if you understand the principle, then with very little work, you can do the sorts of multiple choice questions that have been asked in the past. Okay, now setting up a notes page to calculate average value of a function and the average rate of change. Now, these are often confused, and I suspect that part of the reason they are confused is because there isn't a very good understanding of what is actually going on. So it isn't just a formula, you really need to understand what's happening. So I've set up a notes page, and you'll be able to download this from the TI website. And in a maths box, you can edit that function. You can edit the interval from the A value to the B value. Now, the average value, which is the average height of the graph, I've got the formula here. Now, because you're using a notes page, if I edit that to 3, for example, you'll note that the value changes. If I change the value of A or B, then that will change as well. So this sort of notes page is something that can be taken into the exam, and when you have an average value or an average rate problem, there it is in front of you. The average rate of change, on the other hand, is something quite different. That is the average slope between the 2 points. So the average slope, or the average gradient, is the rise over the run, or the change in y over the change in x. And that's something that's fairly useful to take into the exam with you. Okay, so that's the end of that section.